All right, so let's accomplish the second part of this 3.3. In example 3, we have a special case where we have a fraction that needs to be distributed. We need to solve for a in the equation 3/4 times the quantity a minus 5 equal to 9. Now, I really want you to pay attention, first and foremost, to what we would do to solve this problem. If we were going to work through this problem, we would plug in our a value, then we would subtract 5 and multiply by 3/4. So in order to solve this problem, we would divide by 3/4. We really want to multiply by the reciprocal, 4/3. Right, same thing. Then we want to add 5. So figure out what we would do if we were to plug in. Then we do inverse operations to solve. But this problem kind of ties back into really we could do this problem by distributing first, although it's not the easiest way. Let me show you what I'm talking about. If we use method 1, the idea of distributing first, we would multiply and we would multiply, and we're going to end up with, remember, because those are on the same side of the balance line, so we're allowed to do that without doing any opposites, any inverse operations. We're going to end up with 3/4 a minus 15/4, and that's going to be equal to 9. So now we've got a two-step equation. We need to add 15/4. And now we've got 9 plus 15/4. Oops. So we have 3/4 a equal to, well, 9 is really 36/4. Plus 15/4. 36 plus 15 is going to give me 51/4. 51/4. And I'm going to multiply both sides by 4/3. Look at all this ugly fraction work. Blah! Multiply by 4/3, because that would give me 3/3, which is a 1. And 4/4, which is a 1. And look at all this work, my balance line's not long enough. So I end up with 1a equals, oh look, 4/4 becomes a 1. 51/3, it actually works out to be 17. So a is equal to 17. Look at all that ugly fraction work that we had to do. In comparison, if we use this inverse operations, right? What would I plug in? All right, plug in that a value, then I would subtract 5, and then I would multiply by 3/4. Because I have a quantity, right? Please excuse my dear Aunt Sally. We work inside the parentheses first. When we work backwards, SADMAP, that add 5 is part of the parentheses. So it feels like it's out of order, but it really isn't. So that here, we don't want to divide by 3/4. We want to multiply by its reciprocal. So we'll multiply by 4/3. Whatever I do on the left of that balance line, I also have to do on the right. So multiply by 4/3. 9/3 becomes 3/1. 3/3 becomes a 1. 4/4 becomes a 1. So I now have 1 times the quantity a minus 5, which leaves me with just a minus 5 is equal to 3 times 4 is 12. Remember, that's really over 1, right? 9/1. Or now 3/1. So 12/1 is just 12, because I multiplied 3 times 4. And now this is a nice, easy add 5. Oops, I didn't want that equal sign. I wanted a plus sign. Add 5. So that equal sign's not really there. A is equal to 17. Look at the work and look at the work. They are both acceptable. My work will most likely have method 2 on it more often than not. You have 2 practice problems. Would you please do the one on the left using your fractions, using method 1, distribute first, and use method 2 in the second problem. So multiply first. In your homework, I don't care which order you do it in. Give them a try. Alright, I hope you paused and I hope you went back and looked at these. Notice that I went ahead in that first problem and I wrote down my list of what I would do if I plugged in a value. Multiply by 4, then subtract 2, then multiply by a half, which means that when I go to solve, I should really multiply by 2, then add 2, and divide by 4, if I weren't going to do the distributive property first. Same thing over here, except I didn't write the list down because it's actually what I did. I would multiply by 2, add 4, then multiply by 5/6. So undo that multiplication with multiply by the reciprocal. Then I subtracted 4 and finished with divide by 2. I'll see you in the next video, I believe. Let's double check. Yep, 3.4 will be variables on both sides. If you're not using your balance line, I suggest you start doing it.